Hello friends, welcome to yet another video. In today's video, let us discuss a new topic, why System Verilog. Though this topic appears to be very new and surprising, but I know that many of the fresh engineering graduates who have come out of their college and who wish to enter the core domain of VLSI design always have a doubt in their mind. What is the System Verilog and why System Verilog? Because many trainers might have taught them that either VHDL or Verilog are enough for VLSI design. Yes, no doubt, they are very important. Especially languages like Verilog, which is similar to C in many respects, appears to be more promising also. No doubt in that. So, before discussing why System Verilog, let us first explore what is actually this System Verilog. This System Verilog is not only a hardware description language, but it includes all of the features of hardware verification language, which normally we call HVL. Hence, the engineers also call this as hardware design and verification language. Also, many designers believe that System Verilog is the first truly industry standard language to cover design, assertions, transaction level modeling, and coverage driven constraint random verification. Of course, some of these terms may be new to you. Probably I may try to explain these terms clearly in future videos. Also, the System Verilog has almost similar structure and syntax of Verilog. That is the most important thing. But with many extra features, either in terms of data or in terms of constructs, in terms of always block, so many. So that's why the System Verilog is a superset of Verilog. So learning System Verilog is not that difficult, and writing a test bench in System Verilog is also not that complex. To understand this syntax and structure and constructs available in System Verilog, let us consider a simple design example of an 8-bit full adder. I am presenting this only to give you a feeling that the System Verilog is not Greek and Latin. This can be easily understood and learned. Let us see. 8-bit full adder. As you know, there are two inputs A and B and one carry input C in, and there are two outputs. One is a sum of 8-bit and carry out of 1 bit. So this you know already from your digital design, and this you have already seen how to design using a Verilog code with the different abstraction styles. I have explained the same thing using gate level model, using data flow model, using behavioral model also in my earlier videos. Let us see how different the System Verilog code is from the earlier. So the first line is module. As you know, this is a keyword module for Verilog also, and the next is followed by the name of the module. They are also same. Here we write the port list. That is, sum is the output, C out is also the output, A, B and C in are the inputs. So in the next lines, these are all directions of the port. That is, A and B are ports, C is also input port, and outputs are sum and C out. But the one interesting word that you see here is logic, which you do not see logic. Actually, in Verilog, we write either wire or reg, normally wire or reg in the outputs. But there is a lot of confusion. The industry felt that there is a lot of confusion in this wire and reg, and they are not properly representing the correct meaning. So the system Verilog is provided with a common word logic, and automatically the compiler will take this either wire or reg depending on the need. Therefore, the user need not bother about it to write whether it is a wire or reg. Simply if you write logic, it will be enough. This is the advantage and addition also in your system Verilog. I have chosen logic. Rest of the things are same as Verilog. Then what I have written? Logic. I have defined one more thing, result, as a 9-bit data. So why it is 9-bit? We'll understand. When I add two 8-bit numbers, there will be one carry. What will be that carry? Carry will be the MSB. MSB will be the carry, and the remaining bits will be the sum. Sum and carry, as you know. Therefore, what I have written here, result is assigned, declared as a 9-bit data. Now, what is the statement? Assigned result is equal to A plus B plus C in. So when I use this, result is equal to so and so, then how do I am using the assign statement? So continuous assignment statement, assign sum is equal to result of this. That means the 8 bits of the result are assigned to sum, and the 9th bit is assigned to cout. That is carry out is assigned with the 9th bit, that is your MSB, and these 8 bits are sum. So this is same as you see in the case of Verilog, and end module here also the same. So if you observe carefully this system Verilog code, it is very much similar to Verilog, except that it has very interesting additional features which makes the things more simple. So when compared to Verilog, and system Verilog is found to be more interesting and simple also. So why system Verilog? It is proven fact that system Verilog is the industry accepted hardware verification language. If you consider the VHDL or Verilog, there are some inadequacies, there are some limitations. What are the limitations? They support for high-level data types, OOPS, object-oriented programming, assertions, functional coverage, and declarative constraints is very poor. They don't support these things. Verilog do not support the assertions. That is one of the most important thing in verification, because as you know, in any design, verification play a very important role. If, for example, if the time taken for one tape out of a chip is, say, for example, 100 units of time, in that nearly 60 to 70 units of time is spent on verification. That's why in the industry there is a quotation. If there are 3 or 4 design engineers, there will be nearly 5 times verification engineers. Nearly 5 times verification engineers. That is the importance of verification in fabrication of a chip. So when compared to Verilog, system Verilog will give more advantage for verification. So also the code size in system Verilog is relatively compact when compared to the so-called conventional HDLs. Also the feature, another important feature is the feature direct programming interface allows the C functions to be called directly from system Verilog. This is the most important thing, and vice versa. Either you can call from C to this or this way, the opposite way also, without using the PLI. PLI means programming language interface, which are very widely used, these concepts, especially in designing the test benches. So many extensions to always block for modeling combinational, latched or clocked process are provided, which were not available either in VHDL or in Verilog. This is also another advantage of using system Verilog. Of course, there are some companies which do not take up any branded or any specific verification language also like System Verilog, because they found that these languages have not given them proper efficiency. That is, they found that there are some bugs at the end of the fabrication, at the end of the tape out. So they may use their own verification languages, but majority of the companies still they use System Verilog for verification. That's why the System Verilog is considered as the most sought after language, which is called hardware description verification language, and students are normally encouraged because majority of the test benches or stimulus are written in System Verilog. Therefore, the students are encouraged to learn the System Verilog after their graduation if they want to enter into the field of VLSI design. Because as I've also told you, when compared to the design, that is, when compared to a physical design, the verification has much more opportunities in industry. So through this video, I try to explain some of the interesting features related to System Verilog. Also, the designer can't use a separate language for verification if he opts either Verilog or VHDL, as there are so many integration problems. Another important thing is, if I choose a Verilog or VHDL, I can't use the languages, separate languages, one for design, the other for verification. So I can use an integrated language like System Verilog, which can be used effectively for both for design as well as verification. Also, technically speaking, all VHDL capabilities are directly available in System Verilog. Another important thing. Again, the System Verilog unifies all the points mentioned above under a consistent syntax, coherent semantics, with minimal race conditions and with global optimization opportunities. So, this is the importance of System Verilog. Thank you for watching. Good luck.